So one of the first things that we talked about just briefly was today when we do proofs, you can't move things across the equal sign for convenience. In fact, you're going to notice that when I give you your tests, quizzes, and that sort of thing, worksheets, there's going to be a bar there. Same thing when you get to your provincial exam, it's going to have a bar just to remind you, you can work on one side, you can work on the other side, you can work on both sides, but you can't move things across yet because you haven't proven them equal. So this verifying whether two things are equivalent, it's not really going to be super useful to you because for the most part you're going to be proving something that's true. I mean, it's obviously you don't want to spend the effort proving something that's false, but we can verify it by plugging in the values at an angle. So okay, so we'll just show you what I mean. You can verify this, so we can pick any angle. How about we pick 50 degrees? If it works everywhere, it should work on anything. Well, I guess it'd be 50 radians for my calculator mode, but again, it should work for anything. So you should be able to pick any number, and then we'll divide this by 1 over the sine of 50. So the left side is 0.06884, and we can double check and see what's 1 minus the cosine of 50 squared. It's the same thing. So, you know, you wouldn't want to do a proof if if you found one example where it didn't work, you wouldn't bother doing the proof anymore, right? You can also verify it graphically. You could go and plug in the equation as tangent of x, cosine of x, and we're dividing it by the secant, or sorry, cosecant. Well, I guess I could have picked a little bit better of a window, but just zoom in a bit here. Let's go -5 to 5. And that's a bit better. Okay, so that gives you an idea of what the left side looks like. By the way, if you want to pause your graph, if you hit the enter button, I believe it's the enter button, enter or on, one of those pauses it so you don't have to wait for the whole thing to finish. So we'll put in the other equation just so you can compare them. 1 minus the cosine of x, and I'm squaring it. So it's not going to be the two of them overlap so much you're not going to see them. But one thing that you can also do is, I'll show you once this is done, because of course I have to wait for it, but let's see here. So I'll pause it. You see these highlighted equal signs? That's what your graphing calculator is actually going to show. So if you put the cursor there and you unhighlight it, that graph will no longer be showing. It'll just go back and draw the one graph out of the two. So if you had, you know, multiple graphs and you wanted to see which one it was actually showing, then you can alternate them by highlighting or unhighlighting that equal sign. Okay, so we're not going to go through this process anymore today, but it gives you an idea that it's the same graph overlapping each other each time. So that would probably be convincing enough for you to want to try an algebraic proof. Okay. So let's see if we can, you remember some strategies that we talked about? What strategy might you want to employ here to do this proof? Yeah. Let's start there. We'll turn everybody into sines and cosines. So I'm going to rewrite this as sine of x over cosine of x times cosine of x all over 1 over the sine of x. Now, your work has to be like legible enough to follow. It shouldn't look magical. Like I should be able to understand what you're doing. So usually people like to work vertically. If you're going to move horizontally, make sure I can see with an equal sign or some easy way to follow it. But the next thing I'd be putting down on here is this is that's just the sine of x then divided by 1 over the sine of x. Some of you might be saying, well, yeah, but Mr. Joyce, I could just jump to this. I can see that just by looking at that fraction. I can go bam right to sine squared x. The problem is if you make too big of a jump and I don't believe you, you don't have anything to argue against with me because you've left steps out. You've taken too big of a jump because there's not too many steps then between the question and the answer. This is called a gap in your proof. So if somebody was, a professional mathematician doing this kind of stuff, that's where they'd be saying, your peers would say, I don't understand what you've done in this step. You need to elaborate more. And then a miracle occurs is not the one that we're looking for, right, from that comic? Anyways. So this is the identity I'm going to use to get the rest of the way. Sine squared x is equal to sine squared plus cos squared equals 1. So sine squared x is 1 minus cosine squared x. And now that I know the left side equals the right-hand side, this is the abbreviation you're going to see if you peek over some of the ministry documents. It's just left-hand side equals right-hand side. It's your way of saying my proof is finished because they're equivalent. A couple other ways you'll see it is like this. I don't know where black box came from, but that tends to be a university text. And if you're really old school, you like to write it like this. I'll let you Google what it means. Okay, so again, we did this one all on the left side. You don't have to do it all on one side. You can work on both sides if it's more helpful to you. You could have gone and changed this one to sine squared x if that made more sense. You don't always have to work on the left side. You can work on the right side, wherever you like. So you give this next one a try over here and see if you can prove that 1 minus cosine 2x over sine 2x is the tangent. So we'll practice and talk strategy when we do some of these. First of all, usually the strategy that I pick is you've been drilled to death for the last, 10 years of your schooling that your job is to simplify things in math. So if I had to give you a choice of simplifying something or expanding it out, most of you would be more comfortable simplifying, which is why I'm going to work on the left side of this equation. There's more stuff to cut down, all right? Because there's only a tangent on the right, and you could prove it the other way, expanding it out, but that's generally not the way we've been practicing. So if we're going to start on the left-hand side here, one of the clues is this. It doesn't seem like much of a clue, but you don't want a 1 to be there when you're done because there's no 1 on this side of the equation. So if there's no 1, we're going to pick one of the identities that will remove it for us. So here's my choices. Cos 2x is cosine squared x minus sine squared x. And 1 minus 2 sine squared x. And 2 cosine squared x minus 1. So which one of those top, middle, or bottom ones will knock out, if I stick it in here, the 1's going to disappear? Yeah, the second one. You have to be careful because it's going to be subtraction. So 1 minus negative 1 over here, that would be a plus 1, right? Now you have 2. You didn't have 1, now you have 2. It'll still work, but it just means you're going to have to go that much further with it. The middle one here is going to end up knocking it out. It's going to make life easier. So that's the one we're going to go with for strategy. And there's only one identity for the bottom. So we might as well put the bottom identity in too because there's only one choice. Now, you'll notice that I went to the trouble of writing that in there. I didn't simplify it all in one go. Like some people might just think, oh, well, you know what? I'm just going to write this down as 2 sine squared x over 2 sine x cos x. You've jumped a step. You've missed this one here. You may end up losing marks whenever you jump steps, so really take the time, present it nicely, present it neatly. This is like fine china to mathematicians. It should take the time it deserves to make it look pretty, okay? So don't skip things. It's not to your advantage to move that way through your work. So the next step then, I would do that simplification. 1 minus 1 is gone. Subtract negative 2, so it's positive 2. I always pretend like I'm writing the proof for an audience. Like I'm obviously am because I'm writing it for you. But when you're writing it in your notebook, don't just write it to see that you know how to do the proof. Write the proof down as though someone was going to read it and follow your work. If you don't think someone else could follow your work without you having to explain it, you probably would lose marks. Okay, so 2's are gone, the squared and the sine would be gone. So that leaves me with sine x over cos x. And just to show you that you can work on both sides here, I'll rewrite this one as sine x over cos x. And now left-hand side is equal to right-hand side. So we're done. Okay. Can I move this down? Is that okay? So the next technique is, it's one that you're going to recognize. It's not dead obvious, but once you get the hang of this, there's a bit of a pattern here. And this is what you'll notice when you see it. And it's screaming out for something which we're going to call the conjugate. So the conjugate is when you have something like, you would have done this with radicals. You had like 1 plus root 2, and you multiplied it by 1 minus root 2. Like this. Does that sound familiar? So the conjugate is like if you have a plus b, the conjugate is just when you subtract them. Okay, so I'll show you why this works nicely in trig, but you see I've got them both here. 1 minus cos, 1 plus cos. So we're going to pick a side. Doesn't matter, left or right. Which one do you want to try? Right? Okay. I know we said both, but I guess we'll be different here. I'm going to multiply by its conjugate. So on this side, it would be 1 minus cosine of x because I've got 1 plus cosine of x. If you started it on the left side, you'd do that with 1 plus cosine because you already have 1 minus cosine. So what I'm going to end up with when I do that multiplication is sine x times 1 minus the cosine of x. And does anybody remember what happens when you do this? 1 plus cos x times 1 minus cosine of x? It's a pattern that you've... Yeah, it's the difference of squares. So this is the difference of squares pattern. You would have seen it something like, you know, x minus 3 times x plus 3, and what you got was x squared minus 9, something like that. It's the same pattern, but we're using those trig identities now. And the reason that the conjugate works nicely is, does anybody recognize what this is? Yeah, that's one of the Pythagorean identities. So now I've got sine x, 1 minus cosine of x, and that's sine squared. So I can remove that and the exponent, which leaves me with 1 minus the cosine of x over the sine of x. So it's not that that question is really like a challenge. It's the problem is seeing that technique and knowing that it's there for you. Okay, so when you spot that pattern, you may end up needing to use it. Another technique we're going to work on here, strategy-wise, is factoring. So this next one here, I'm going to ask you to try proving it yourself, but I'm telling you ahead of time, consider using factoring as a strategy when you try this next one. Okay? Now, I know one of our strategies has been just to revert back to all sines and cosines, and that'll work in this instance as well. So don't feel like you can't do that here, but the fact that I have a secant in a couple places and I can factor it out, it probably means I'm going to need to factor somewhere in here. I might not have to, but it probably will make the work a little easier to deal with. So I'm going to for those of you who did replace it all with sines and cosine, you can just compare to see if you think this would be any, you know, better of a strategy. But if I started by factoring it, then I've got 1 over cosine times 1 minus sine of x divided by cosine. So it's going to become 1 minus the sine of x over the cosine squared of x. So this fraction will end up moving down like that, so I have 1 minus sine x over cos squared x. So is this okay? Are we with me so far? Okay. Now, if you look at where we're at and where we're headed, well, it's kind of tough to see how am I going to get this piece here to look like this piece here. But hopefully you still remember, since it's fresh in your mind, that there's that other thing that I just showed you called the conjugate. So I could multiply by 1 plus sine x over here. Or I could multiply on the other side by 1 minus sine x. So I'm going to keep going here just because I have more room. I don't have a good answer for you other than I've got more room to work here. I didn't leave myself much space. But if I was to use the conjugate on this side, I'm going to end up with 1 minus the sine squared of x over cos squared x and 1 plus the sine of x. So this one I hope you're starting to recognize is cosine squared of x. So these would be gone, and I'm left with 1 over 1 plus the sine of x. So they're both the same. So I think just to show you a possibility here as well, I think I will just try this question again using sines and cosines, in case that was something that you feel is more comfortable to you. So I'll just rewrite it on a fresh slide here. Oh, it's minus? Thank you. What was it? Cosine? Okay, so again, if I was to do it cos x minus, just get all back into sines and cosines. Then I have these complex fractions. So I have to figure out what can I multiply through. You can make common denominators and do all the flipping and multiplying, but let's go past that. Let's take a look. What could you multiply by here that would get rid of all the fractions on the top? Cos x. If I multiply the top by cos x, that would be beautiful. They would be disappeared. So I have to put it on the bottom as well, or I haven't balanced out this fraction. The bottom has no complex fraction. I don't need to do anything to the bottom. So now I can move on by multiplying. Cos x times 1 over cos x, that's going to be 1. Cos x here, all I'm going to be left with is the sine of x. And then cos x times cos x would be cos squared x. And again, we're at the point where we would use the conjugate, but if that's the way you set it up in all sines and cosines, this is just to show you, yes, it does work. You're going to have more fractions to deal with, but if you're confident in the way you work with fractions, that's probably not an issue. Sorry, did anybody need to see that slide a little more? Okay. So these last ones here, I'm going to come around and see how we're doing on them. Factoring, again, is going to be one of the things that you should consider when you do these if you're getting stumped. So I'm going to do this one on a fresh slide just so we got lots of room to work it out. So if you don't know where you're headed with it, you may as well start making some switches. Like for example, on the left side, I don't know really what else I'd do to this other than start with cos x over sine x minus 1 over sine x. And then I might say something to myself like, oh, well, they already have the same denominator, so why don't I keep going? This would be cos x minus 1 over sine x. And now I'm stuck. But I'll go to the right side, and I'll try and work on the right side for a bit, right? So if I'm looking at this, the bottom one, there's only one exchange that I can make. So I definitely know the bottom I'm going to turn into this. But this is where it starts to get tougher as far as you need to picture a few steps ahead when you work, right? You can't just start going through the step 1, step 2, step 3, and out pops an answer. If I look at this, I can see that there's a sine x on both pieces. And this comes from experience. It'll happen for you too. But sine x on both means I'm going to be able to factor it out. If factoring is what I'm looking for, that's going to be my strategy here is what can I do to make some factoring happen? So if I choose out of those identities for cosine of 2x, I've got cos squared minus sine squared. I've got 2 cosine squared x minus 1 and 1 minus 2 sine squared x. I don't want to pick either of these, because if I choose one of those, I'll have sines and cosines all in it, and that will be something I don't want to work with for factoring. If I choose this one, I'll have all cosines in my problem, something I stand a good chance of being able to factor. And in fact, that's what we will be able to do after I make that replacement. So you need to think of this as, I'm going to rewrite it. We'll go one step at a time here. 2 cosine x squared minus the cosine of x minus 1. And this will be sine of x, 2 cos x plus 1. And what you need to think of this piece as, in case you forgot from trig equations, I'm assuming you still wake up with nightmares from them, but screaming over trig equations. That was the way you were supposed to think about it, right? Was 2 cos squared x minus cos x minus 1. It's a lot like this thing you've already been dealing with for a couple of years. So that I can factor, and I will. The method that I use is this sort of magical one where I go cos squared x minus cos x minus 2. And then I think about the pieces I could use to make that happen. And I'm going to get cos x minus 2, cos x plus 1. And then dividing both by 2, the number I had already multiplied by, gives me cosine x minus 1 and 2 cosine x plus 1. And it's kind of a giveaway as well. If it's going to work out and it's going to factor, that has to be one of the factors, 2 cos x plus 1, or I didn't get any further with the problem. So I'll make my next replacement. That will be cosine x minus 1 and 2 cosine x plus 1. And sine of x times 2 cosine x plus 1. So those pieces are gone, and all I'm left with is cos x minus 1 over sine of x. And at this point, I can see left-hand side equals right-hand side. I'm done. So the factoring part there, yeah, that was tricky for sure. Basically, once you can't if you can't make any more replacements using your identities, factoring is one of those things you're going to have to consider. The conjugate's another one I showed you today that you'll have to consider in your list of tools. So there's one last and final trig proof we'll do together for practice. Has anybody started this one yet? Okay, I'll give you some time then to work on it. Okay, so I'll do the last one here. If you're still working on it, you don't want to see how I'm answering it, just keep going with your head down. I'll start making some replacements where it makes sense, and then hopefully something will pop out where I'll be able to come up with the proof. So the first thing is, I know I'm going to make this switch. There's no other alternative. And then I'm going to do some factoring. I can take a cosine out of there times 2 sine x minus 1. And on the bottom, I can actually see, now that I see this is part of my proof, then I'm going to take a look here. This is a difference of squares. That's like 2 sine x squared minus 1 squared. So if you remember this pattern, the way it gets factored is 2 sine x minus 1 times 2 sine x plus 1. And of course, that gives me my first thing to drop out. I get cos x over 2 sine x plus 1. And I'm probably doing all right because now I can see I've got the same denominator. So I know I'm getting closer to the answer. So you may not want to work on this side expanding, but what I can do is I can move to the other side then and simplify this down. So I'm going to factor out cosine on this side. And I'm left then with sine squared x plus cos squared x. And I know at this point that I don't really want to mess with the denominator because it's already matching the left-hand side. But this identity here is just 1. So I'd be left with cos x over 2 sine x plus 1.